My name is Masahisa Kawashima. I work for NTT, but today I'm representing a global community called IOWN Global Forum, where I'm serving as the chair of the technology working group. And I'd like to introduce our activity explaining the importance of collaboration between Linux Foundation and IOWN Global Forum for the evolution of network and edge. Change. Okay, so I'd like to start this presentation with shared interests. We, infrastructure engineers, should address these three demands from societies. First, we should support societies or industries becoming more data-driven. And second, we should enhance resiliency and security. And third, we should address the sustainability issue. So that means the infrastructure should be more energy efficient. And as you see in the bottom half, of course, many people are making a lot of efforts to address these issues. For example, companies like NVIDIA and Broadcom are developing frequently upgrading their device. And to leverage such devices, some consortia are defining new interconnect or data transfer methods such as RDMA or Ultra Ethernet or UAL and so on. But of course, we don't want our infrastructure to be dependent on vendors' proprietary technology, so we are promoting disaggregation of infrastructure with open interfaces. And many of such activities are trying to make infrastructure automated or autonomous to achieve enhanced reliability or resiliency or energy efficiency. So as a result of these efforts, some infrastructure have become with more capacity and more resilient and more energy efficient. But I have to say that such infrastructures are limited to those inside the cloud. But the rest of the world, still the infrastructures are not evolving at the same speed. That's why today, ED, STL Partners, has suggested that there are billions of opportunities for edge AI. But so that is aligned with my observation. But probably what I'm trying to say here is there will be several ways of approaching that opportunities. So solving this problem, I mean, the bandwidth gap or efficiency gap between inside the cloud and outside the cloud is very difficult because this is because of the whole structure of today's network. As you see here, typically today's optical transport systems cannot be operated with frequent reconfiguration. So I would say that the optical transport resources cannot be treated as software-defined resources. And because of that, typically when operators provide network services, they have to deploy many routers and switches to implement service features such as high availability and security and so on. But if we deploy many routers or switches, then the infrastructure capex would go up because when routers and switches should be frequently upgraded based on Moore's law product lifecycle. So that's one of the reasons why the carrier's bandwidth cost is very high. So, and also, even if carriers put heavy investment and provide high-speed services, users' experiments would not change so much because when users transfer data with TCP/IP, basically it takes time to transfer the big data. So this is today's problem. However, we might be able to change this situation by leveraging the evolution of optical communication devices such as pluggable optics and co-packaged optics. So for example, DWDM transceivers used to be very large and cannot be deployed on customer sites. But today, DWDM transceivers have become so small that they can be installed into customers' routers and switches. So this will be an enabler for the breakthrough. So as you see in this slide, if you put DWDM transceivers, deployed DWDM transceivers at customer sites, and connect customer sites directly with DWDM, then the one no longer have to have routers or switches. So the bandwidth cost and efficiency cost, the bandwidth and efficiency of one will be significantly improved. So that means we can create a new edge computing paradigm where multiple edges and multiple clouds are interconnected to form a seamless computing space. Today's edge computing, I think, is based on the assumption that clouds and edges are divided by a slow and expensive one. But with a new paradigm, clouds and edges are interconnected to form a seamless computing platform. And this will be a strong platform for new cyber physical application systems. But you may say that this is not possible because there are a lot of challenges. Like you see here, ROADMs today are not ready for such scale. Or with TCP/IP-based transfer, the data user's experience will not change so much. And what about security? We need firewall anyway. So there are a lot of challenges to change this paradigm. But some people think this is worth the challenge because it creates a new powerful platform for many applications. And this is achievable with global collaboration. So this is where IOWN Global Forum is established. So IOWN Global Forum was established in 2020, and it's a nonprofit organization, and the mission is to develop next generation computing and networking infrastructure, leveraging the evolution of optical communication and photonic electronic convergence technologies such as co-packaged optics. And this is an example of edge cloud computing system with IOWN Global Forum technologies. As you see at the bottom, we have a distributed ROADM infrastructure called APN, or photonic network. And this will provide DWDM-based software-defined optical transport. And at the endpoints of APN, we would deploy packet optical gateway that can be operated with QoS-aware connection management. And so packet optical gateway will provide Ethernet virtual connection with deterministic quality, and then nodes are connected with smart NICs. And smart NICs will be capable of RDMA-based data transfer, and also be capable of security policy enforcement. So with this, edge, the data from edge to the data at the edge will be transferred to the cloud with RDMA. We call this technology called RDMA over APN. So we can create a data pipeline that can be operated at the speed of optical communication. And as you see in the previous slide, so we are not focusing on a specific layer. Instead, we respect many other consortia that are focusing on the development of a specific layer, such as OIF, or Open ROADM, or TIP, and so on. And our activities at IOWN Global Forum is focusing on the redefining full-stack end-to-end system architecture to achieve quantum leaps in latency or capacity and energy efficiency. So we are defining how building blocks are composed to achieve such improvement. And this is an area of activity. And let me talk about APN a little bit. So APN is basically distributed DWDM infrastructure supporting SDN-based operation. And of course, we are thinking that transport PCE can be used as a APN controller. So basically, our activity is aligned with transport PCE activity. But what I'd like to highlight here is that OpenAPN will make transport PCE more important because APN will extend the endpoints of DWDM to site. So the role of controller will become more and more important. So I expect that we would have more opportunities to collaborate with transport PCE team. So I think some of you are thinking that even if this is technically possible, we cannot create a market. It's very difficult to change people in the market. So now I'd like to introduce our activities to drive the market adoption. So we think that the key for success is to engage technology adapters. So at IOWN Global Forum, we have many companies on the technology adapter side. For example, we have MUFG and Morgan Stanley as a financial company. And we have for broadcasters, we have TBS and NHK. And for AI, here AI means we are trying to provide solutions for companies who are trying to develop AI-based products or services. And of course, we have many manufacturing companies in IOWN Global Forum members. And also, we have companies from the construction industry. And also, of course, we have telecoms. So the key is to engage such technology users and identify their business agenda that they would like to solve within a few years. And we do this kind of activity and clarify what is the real pain point and what are the objectives or KPI to develop technologies. And we do POC. We do proof of concept. Of course, many of you are doing proof of concept, but in our POC, we take time to clarify the KPI or POC objective so that we can demonstrate the technical advantages of IOWN solutions from the viewpoint of technology adapter side companies, business stakeholders. And based on the result of POC, we sometimes update our reference model, reference design, so that eventually we can develop truly viable and practically operable technologies. And this is leadership companies and members. As you see, we have many global companies from the network and IT industry. And as you see in task force coordinator, there are several companies from the user side, such as MUFG and so on. And the number of memberships has been growing. So this is examples of the current POC activities. Where we are trying to create a multi-data center infrastructure for financial service institutes. And also, we are trying to develop a system for remote video production for TV broadcasters. And also, we are trying to create AI infrastructure that enables many industrial customers to use remote GPU over APN without being concerned about data sovereignty and also without being concerned about the bandwidth cost or WAN. So this is another way of addressing billions-dollar opportunities with edge AI. And the fourth one, offloading edge computing workload for suburban data centers. So that means with edge computing is great. But if we deploy computers on urban areas or suburban areas, that would make worsen the renewable energy balance, so the carbon balance in the downtown and suburban areas. So what we are trying to achieve with IOWN APN is move computers in urban downtowns and suburban areas to data centers outside of central area so that carbon balance can be improved. And the last one is elastic radio access network, which means we are trying to make RAN more cloud native. Well, even if we say today's RAN is cloud native with Open RAN, basically, if we use dark fibers for front hauls, then optical transport cannot be software defined. So you cannot operate with elastic operation. So what we are trying to do is to apply APN to make CRAN really cloud native. So this is my last message. So I think now you understand how the collaboration of IOWN Global Forum and Linux Foundation will create a new world. We will be creating a new edge computing paradigm where edges and clouds are interconnected with high bandwidth, low latency connections to form a one seamless computing space. And basically, we will be the users, I would say, we will be good users of your work. And we will engage more customers that would appreciate your work. So, and if you are interested in our activity, please talk to me or Sugiyama-san, Red Hat, in this week. And also, if you come to Japan, you will see several exhibits that demonstrate IOWN Global Forum technology. So please consider visiting Japan. So this concludes my talk. Thank you very much. I look forward to having nice discussion in this week.